And here's Jean.
Hi guys. Basically, I'm Jean Dupuis. I've been having fun as a data engineer for the past 9 years. I've tackled a wide array of data challenges, and I generally like to fix them in a smooth solution. I think that I've learned over the years that easy does it. Um, and Throughout my career, I've actually started more on the OLTP side, which is transactional, and I've progressively migrated into the OLAP side, which is more analytical. So this segues well into this talk that I'm very grateful to have the chance today to present to you ELT versus ETL, which is a great way to build analytical. Oh, actually stomped on the cable. That happens. Oops. Oopsie. Oh. Um, yeah, it's my fault. Um, uh,
Technical issues.
uh,
Just plug in your HDMI.
yeah, good idea. And replug it. Yeah, good idea. That looks good. Oh, yeah, cool. Thanks a lot, Luke.
Is it possible to take the audio this side so because this we can see the slides?
Good idea. Thanks a lot, sir. Good man. So, right, so, let's dive into today's session, which is ELT, which I really wanted to present to you because I've used ETL many years. And ELT is really great when it comes to analytical workloads and BI and the sort of workloads that the great people from Baringa just presented before. So, yeah, I quite like it. So let's start with a quote, as we usually do. So data pipelines should be designed as flexible workflows, processed efficiently, dynamically, and then validated, which covers a lot of the points that we talked about before. And what is ETL? So I'm sure that the audience is very familiar with this. So but let's study because we'll need to compare with ELT. Within the ETL kind of traditional way of thinking, so you first extract the data from source system, then you transform it inside of an engine like Spark or many others, and then you load it back into a target database or a data warehouse, right? So yeah, that's what you do with ETL. Now, what is EL? Right. I've actually messed up my title. It's supposed to say ELT there, but it's okay. It's ETL to time. Yeah. I was confused myself because they're very similar to each other. So yeah, but it's okay. So what is ELT? So in ELT, data is extracted from source system and then transformed into a suitable format and all of that, and then loaded. Yeah, that's the same stuff. Right. What is ELT? So basically, you extract it from the source. You use the source to transform it, and then you load it back into the source. So everything happens in one place. But throughout my career, I've actually found out that this definition always varies and it's not perfect. So I see ELT as kind of like a goal to attain within an analytical project, and you have to accept that it'll never be 100% perfect like most things that we do, because the hybrid workflows exist. There's always a pesky preloading transformation out there. The intermediate steps vary widely. ETL and ELT tend to, the line between both tend to blur away sometimes. It just did for me. And the best practices are sleeping overall, So, yeah. So just a recap diagram real quick. So, you guys all know ETL, so that's the one on the top. And basically within ELT, you just transform the data using the same database or storage system as the one that stores it, So yeah, and historically, ELT used to be very, frowned upon, but with the modern data warehouse, which we'll see afterwards, it's very powerful and it works very well, and it scales very well as well. So yeah, um, I've actually prepared a little game for you guys. So basically, we will use our hands a little bit, and we will basically, I will show I will show you a few scenarios, and we will need to classify it within ETL and ELT. So if it's ELT, you can do that, and if it's ETL, you can do that. So that's for ELT, of course. Okay. So I'm going to show you the first one on the screen. So stored procedures on Postgres, Oracle, MySQL, and SQL Server. How would you classify that? ETL or ELT? ETL. Yeah, cool. Personally, I would, classify it as, garbage, but it'll have to go into ETL, because that's where it's supposed to go. Stored procedures are really like a nightmare. It's classified as ETL because, even if it's transformed by the source system, when, like data comes in, it's actually like transformed live on a per row basis. And there's an element of batch to ELT that this, let's call it an architecture, is lacking, So yeah. Now, next one, transforming data in real time using Kafka Stream, KSQL, Spark Streaming, or Flink. How would you classify it? ETL, cool. So yeah, I would do the same. It seems very obvious to you guys because basically, it's kind of coupled, and and it's live. Now, transforming data in Spark in batch mode and load it back into the same source. How would you classify it? ELT, cool guys, cool. Yeah, you guys got it. Yeah, that's the very definition here. Now, bundling data transformation into the batch API pool process. That's ETL, yeah. You guys got it. Yeah, so basically this one is ETL because you do the transformation at the same time as you load, so that's ETL. Well, before loading, so that's ETL. Now, plugging dbt into your data warehouse to transform data. Yeah. I want to see a big one for this. Yeah, those who know me will know that I'm a huge fan of dbt, and I never miss an opportunity to promote it actually. Yeah. So so it's ETL definitely. So yeah, let's look at the benefits of ETL versus ELT. So let's start with ELT. Generally, there's a faster data loading. Now, I don't want to be mistaken, faster in terms of throughput, not in terms of refresh intervals, It's more scalable, especially with the modern data warehouses, as you can kind of plan your compute to happen around the batches. There's a stronger focus on data quality and logic. For example, for a project like the one that was presented before, which is a very good BI use case, I would definitely go for ELT. This is really because everything is in one place, so it really puts an emphasis on your data quality, and it's more queryable, and it's already aggregated and all. So yeah. Flexibility because it's adaptable to various data sources because it encourages to be able to load everything in one place because you need to. So so generally it has a reduced processing time. So that's very common within OLAP. It's very suited for OLAP. It's more cost efficient because you separate compute from storage, and with modern data warehouses you have lower infrastructure and maintenance costs. I'd say that it's more data governance friendly for those who are interested into that, because then you have all of your ACLs in one place. It's very friendly to the medallion architecture for the Databricks people in the room. It's generally easier to achieve your target data modeling or do any data modeling. It kind of encourages you to. It's very easy as opposed to ETL where it can be a lot of boilerplate to do that. And generally, and that is actually what I've actually observed, and that's why I really like ELT, is that it's more analyst friendly. So, you may have analysts within your organization, who like don't code in Python or like do any pro code, but can do like a bit of SQL, and the modern data warehouses are like easy to plug within Tableau and etc. So it really helps you to leverage their skills and have the engineers doing what they do best from an engineer's perspective. So I think that this one is actually really what made me really like ELT as an engineer myself. So yeah, so no system is perfect, so let's look at the drawbacks. So ELT can be challenging to implement in real-time scenarios, but do you actually need real-time scenarios? That's the like first question that I ask when I'm confronted to a person that like says so, and most of the time we actually don't really need them. And here by real time I actually mean sub 30 minutes. So for like most workloads within the analytical workspace, it's actually not very needed, to compute something like sub 30 minutes. But if you need to, then forget about ELT. It's going to the system is probably going to be a bit too tightly coupled, and it's generally not made for that. Generally, then depends on the implementation afterwards. So yeah, along the same lines, transactional serving can be and OLTP can be a bit difficult. It can be resource intensive. Now, most of the modern data warehouses actually solve that by separating compute from storage and using like Presto model and all of that good stuff. But yeah, you've got to plan your warehouse. For example, if you're running this on like Postgres or like a MS SQL server or those sorts of legacy databases, if you allow me, this can be a bit this can be a bit resource intensive for your warehouse. Yeah. Then you have this. You generally have a separation of loading the data and then transformation, which has a lot of benefits, but it also has like inconvenience, as in generally like the things tend to be a bit more separated into the ELT model. And yeah, generally you have one system that does it all. So we see many people being locked in with Snowflake or like with Databricks, and it's not like a big deal right now, but it might be in a couple of years or so, when the world evolves again. So yeah, these are some drawbacks to like ELT. Yeah. What are great ways to build a clean ELT pipeline? You may ask. dbt is your solution. That's an unsponsored product placement here, as I left to them. So ballpark in the room, who knows dbt? Cool. Perfect. So yeah, for those who like don't know, which is like half of the room or something, basically it's a friendly and declarative way where you just declare things as opposed to like telling the like system how it should do it. You like just declare things to build all of your data modeling and your test and all of your pipeline really and your transformation. If there are some DevOps peeps in the room, I like to call this the Terraform of ELT, or the Pulumi, which is cooler in 2024. Yeah, and the dbt has adapter for the effortless scalability on the cloud, the great lakehouse for those who are still running on Spark, the very well planned way to do ETL on AWS, so you can actually run with Glue. If you're used to doing ETL there, you can quickly switch to the ELT with dbt. Dremio and Trino, which actually lets you query spanning multiple databases. The Redshift deprecated database inside of AWS. Its replacement, Athena, which is really great to query data on top of S3. The Beast, that is BigQuery for the GCP customers. Fabric and Synapse Analytics, which is very popular in the room, I've heard. Oh, shoot. Just a second. Yeah, we've lost it.
Yeah. I think it's coming back. Yeah.
Yeah, and DuckDB as well, the very controversial on-the-fly analytics database, which is very popular. So many people use it and misuse it as well. And our good old reliable Postgres, as well as Oracle and MySQL, and all of those great guys, which are still a decent choice for like small projects. So yeah, What I want you to see here is that DBT kind of integrates with like everything, so you kind of avoid the like lock-in. And if you started with your project and want to move to like Databricks, you'll have very, very minimum code changes to make. So that's cool, kind of like Terraform really here. So that's a DBT model really quickly. So that's how you create like a table. So you don't write any of the boilerplate code. You just write SQL and a bit of Jinja templating, and then you've got it. DBT will actually build that for you, and it will resolve all of the warehouse-specific code. And DBT also resolved like dependencies. So if you mention tables within your model, they will be resolved and built in parallel when possible. So here, for example, the first model will build first, then the like two will will start building after that the first has done, and then they will build in parallel because like don't depend on each other, and then the three will And it's like a command line, so it's a bit like Terraform basically. So you just execute it as a command line, or generally make it orchestrated by something that can execute like a command line, like Airflow. And we'll actually see the architecture right now. So that's your typical DBT ELT architecture. So first, obviously, you rely on a system like the great guys at Portable or Fivetran or Kafka Connect, or things that you'll build to load data into your warehouse. And then, a DBT takes care of this data. So you can run your test, you can run your data freshness, your anomaly detection, all of your data transformation, really. What DBT will do is that it'll be a lightweight component that will just schedule your queries. So you can store all of your queries and your tables that we call models in the community on Git. Then you can run DBT on your Kubernetes cluster, or like serverless Fargate, or Azure container instances, whatever cloud your heart beats for. So
It just takes a second.
cool. So then you generally depend on an orchestrator like Airflow, Prefect, Orchestra, etc. to schedule DBT, and you can see how it blends together. It's okay. It's just the.
It's the Mac.
It's a good. It's totally. So it's a good thing that I was on my last slide. So the way that I feel about ELT, but I feel like ELT these days is a very debatable topic, because it's I don't know. So it's an evolution of ETL, which I think is really specialized for OLAP in its application, and it really integrates with the modern data ware or lake houses, and it's more suited for analytics. That's the thing that you should retain. That, and it's DBT is also great, and it's very easy to build your ELT, whatever your data model is, with DBT. Yeah. Great. So guys, if there are any questions, happy to answer those. Really, if you don't agree about anything that I've said, also, love to debate.
I think you're lying about the unresponsive bit.
I wish.
So I have a use case with IoT data.
Great.
There's a lot of sensor data.
Great.
How would you process that? Would that be best done in ETL or ELT, and process and save it and for analytics?
Well, as always, when you think about a system, the way that it's done these days, when you think about the engineering behind, is to think, how am I going to retrieve my data? Now, for your use case, it seems that you will want to run analytical operations on the data, computing sums and all sorts of aggregate functions, and then all of that. So these are stateful transformation, as we call them, because they need entire data sets. So I think that ELT is actually great for your scenario. So what you need to think about first, if you want to plan a good ELT scenario for your use case, is that you need to pick like a data warehouse. So BigQuery, Athena, Snowflake, or Fabric is great as well. And then you need to extract your like data. So for example, coming from the sensors, and then like potentially load it into Kafka or like something like this, and then load it into your warehouse. And then do not transform it, just load it as is. And then you can transform it all into your like warehouse, and your warehouse can take that thanks to the great like improvement over the last years. Yeah. Have I answered your question? Yeah. Perfect. Very good question.
We've got a chat at the back with the question.
Right.
All the way back here.
Thanks, man.
Yeah, hi there, thanks for the presentation. So, my last line, I won't name because it might be recorded, doing a bit of DBT and doing a lot of big data management, and we, in theory, we don't like using a certain program for transformation. We use it for standardization, but that doesn't always work out. So I was just interested to hear you talk a little bit more about when you think it's a good idea or not, as the case may be, to do some preload transformation, a sort of impure ELT. What are the things that you still think may be a good idea to do before the load?
Thanks, man. So I think that the only moment when it's a good idea to do a preload transformation is if you really don't have the choice. For example, if you want to solve, transform, your like data in real time or like something like this, then it's a good idea. But most of the time, it's a better idea to load the like data that you want to aggregate into your like warehouse. For example, in DBT, we have the like seeds for that, or you can just load it with your own, patterns, and then to just transform it into your like warehouse. I appreciate that this might sound it might sound like a dull answer, but it really is what I think, though. I believe in that working, and conversely, I think that trying to have a transformation layer spanning, multiple system is often, exactly, yeah. So, yeah, very good question, very good question. Oh, we have another one here.
Thank you. Yes, so let's say you've got a system that's like a SQL server, which is your document of record, and then maybe you've got Redis for user sessions and sort of manipulating data and so on. You've got an Elastic for searching stuff. Is that like ELT, or is that lots of small bits of ETL? At what point does that become ELT?
Right. So, so basically, I think that all of this is kind of outside of the ELT realm, as it's very difficult to do ELT on like Redis and like Elastic, which are really good services. But that's why I said that ELT is more suited for OLAP and then like analytical use cases. And then I think that Redis, would be better to serve like a cache of live data. And Elastic would be more geared towards doing relevancy engineering, or providing like a search engine, or some people store logs there. I don't like it personally, but I don't know, perhaps if you want to do analytics on top of your logs, you could. But personally, I think that if I had to do analytics on your stack, I would first load it into a warehouse and then plug DBT there.
Yeah, so you're basically saying the ETL or ELT begins at that boundary.
Exactly. Yeah. So yeah, the ELT, ETL begins at that boundary. So generally, I think that the like warehouses these days are very elastic, and then like very serverless and very cheap, to like store data long term. I bet that it's actually cheaper to like store things in your warehouse than it is to store them in like Elastic or like Redis, perhaps by a factor of 10 or like maybe even more if you don't query your like data frequently. So I think it's really worth it to invest in a warehouse these days, even if your current tech stack is more geared towards OLTP. It's and most organization needs to get started in OLAP at some point. So very good question. Very good question.
It's not a question, but more of a point for IoT systems, because they are exploding in use cases, right? So basically, when it comes to IoT devices, we now have enough computing on the edge device wherein it can actually do certain computation on the edge itself. So you'll have to see what is your use case, because let's say your use case is anomaly detection. you can have a computing device, edge computing device, and then that can do it right there and send the anomaly detection to your database, right? Instead of doing the whole load, because that would be a lot of internet bandwidth usually. Internet bandwidth is most critical component of all the transformations, right? The network cost. So if you want to decrease the network cost, the best case is to basically do the transformation on the edge itself. When it comes to video detection, anything like that, object detection, it just makes so much more sense to do the combination on the edge itself rather than send the data and then do the detection in your cloud, basically. Yeah.
One more question?
Hi.
Hi.
So I'm gonna take it the ETL take it back to the ETL side.
Cool.
So I've not really had much experience working with OLTP like workflows, etc. What makes ETL better suited for OLTP workflows compared to ELT?
I think that the difference between OLAP and OLTP, if we go back to the university books, is basically the real-time effect. So generally in OLTP, you want to retrieve password for a single customer, and in a few milliseconds. Whereas in OLAP, you want to know how many customers have actually got a password, and you can tolerate to have a few seconds or minutes, to get that information. And then in ETL, generally, you'll do, small operations that could fit in a Lambda or something like this. So it's a different world for different use cases. But very good question.
So for instance,
I
guess in terms of transaction tables,
Yeah.
that being OLTP,
Yeah.
because the transaction is going into a transaction table,
Yeah.
it therefore needs to be transformed first before I can even enter.
Yeah.
Yeah. So
Yeah.
okay, yeah, that actually does make sense. Thanks.
Yeah. So that's a great question, and I always recommend to separate OLTP and OLAP. I've seen many people trying to blend both, and it works well on paper, but not in practice. So very good question.
Thank you, Jean.
Thanks for having me on that. Great stuff.
We're going to take a quick 10-minute break, so get another refreshment if you'd like, and then we'll be back for our last speakers of the day. Street.